question. So it says a company extracted 4,500 tons of mineral from a mine during 2018. The mass of mineral the company expects to extract in the subsequent year is modelled by a 2% decrease. So find the total mass of the mineral which the company expects to extract from 2018 to 2040. Give your answer to three significant figures. So let's think about what on earth we've got here. And again, if you're ever stuck, just think logically, what are we doing each time? So I'm starting with 4,500 tons. And then I know the year after, the amount that I'm going to get out is 2% less. So that would be the same thing as multiplying it by 0.98, wouldn't it? And that would get me what on earth I'd get in the second year, assuming this is year one. And then if I then take year two, I know that every year it decreases by 0.2%, by 2%. So if I take the year two value and times that by 0.98, that would get me what I'd get in year three. So can you see it's a geometric sequence because it's going to be times in by 0.98 every time. So that gets me my year two value. So the first thing is identifying that. And it's like almost, like compound interest formula. It's like that. It's basically your initial value, which is A, times by the, we'll call it R for now. So we'll see where the geometric sequence is there. So the original value times by the common ratio here, which will be your percentage of your original value, to the power of the number of years minus 1. Because you think about it, year 1 is the initial value. So, because for example, you wanted year 1, it'd be r to the power 0, which would be 1. And that'd get you the total in year 1. And then year 2, you'd want to times by 0.98 once. So that is a geometric series. That's what we're basically showing there. So your first thing is to work out that it's asking you about geometric series. It's not maybe so explicit in the question, but that's what it is. So AR to the n minus 1. But let's think about what we're actually being asked here. We want to know the total mass. So basically we want the sum. So the sum of a geometric series is this formula, and this is in your formula booklet. So it's A1 minus R to the power of n all over 1 minus R. And we don't want sum to infinity because we know we want it between the years 2018 and 2040. So it's just going to be the sum of a geometric series. So let's first of all think about what n is going to be. So n, and it's quite easy to make a mistake here because we can basically say, well, we want it between 2040 and 2018. So if I do 40, take away 18, that's 22. But that doesn't include the year 18. That's basically from 19 onwards. We want to also include that first year. So because that doesn't include that, you'd have to actually add an extra 1 on for the year of 2018 as well. Because remember, that's just the difference between 18 and 40. It doesn't include that first initial year, which is 2018. So add an extra 1 on. So n is 23. Hopefully that makes sense. I know it's a bit hard to get your head around sometimes. But n is 23 because we want to include that initial year as well of 2018. So then it's just a case of bugging it in the formula. Let's also define what our other values are. So our other values, so A is the first term in our sequence, which is 4,500. Actually, let me just check that. I'm just going off memory. Yes, it is. And then the common ratio is what we're multiplying by each time. That is the percentage multiplier of 0.98, which is associated with a 2% decrease. So the sum of the first 23 terms is going to be, 4,500, 1 plus 0.98 to the power of 23, all over 1 minus 0.98. And then we just put that in on our calculator. And that is going to get us, 83,621.86152. I'd write out the full value and then I would round it afterwards because it does ask us to put it to 3 significant figures. So one time I'd write out the full value first, because if you do somehow make a mistake rounding, which it happens to the best of us, that's what I get. So 83,600, and it was tons, because it was looking for a mass, and the mass was tons. So that's part A of my question done. So it's the sum of a geometric series. So let's have a look at part B. So part B says, find the mass of the mineral which the company extracts during 2040. Give your answer to 3 significant figures. So this is just using the formula to find just one term in the geometric series, which is AR to the power of n minus 1. Which, like I say, it's the same formula basically as compound interest. It's just a different way of writing it. Compound interest is a geometric series, basically. So our first term was 4,500 times by our 0.98. Now, n minus 1. So n was 23, remember? So it would be 22. And from a logic point, because we don't, the first year, we're not multiplying by that 4,500. That is the first year. So if we wanted the second year's value, it would just be 0.98 to the power of 1, if that makes sense, because you're not including that first year, because that's your first term. You don't need to multiply that by anything. So it would just be, that would be the what you get in 2040. So if we get that, so I get 288, sorry. So 2885.268, and then that rounds to, again, I think it wanted it to 3 significant figures. It did. So 3 significant figures, that is going to be 2890 tons. So that's all it was. So you can honestly think about it like compound interest, but it's just a geometric series. And as long as you identify that, I think the question is quite accessible.